So we are going to start chapter 12. Chapter 12 is a continuation of the ideas that we had discussed in chapter 11, which is the relationship between risk and return. And before we can define that relationship, we had to measure what risk is and what return is. And much of that we have done in chapter 11, how to measure return and how to measure risk, how to measure expected return, and how to measure standard deviation, which we defined as a measure of risk. We also talked about a little bit about systematic risk and unsystematic risk. Risk that is common to all stocks, which is the systematic risk, and unsystematic risk is risk that is unique to a stock. So what in this chapter we will do is we will try to combine stocks into portfolios, and then we will learn how to measure systematic risk, which is the most relevant measure of risk, the systematic risk, because in a large, well-diversified portfolio, unsystematic risk should drop out, should cancel each other out. If you diversify your portfolio by adding different stocks to the portfolio, then the unique risk component of those stocks begin to cancel each other out, partly because when one stock may have a good news, another stock may have bad news, and they will essentially cancel each other out. But what remains in the portfolio, the risk that remains in the portfolio is the systematic risk, which cannot be diversified out because it's risk that is common to every stock in the economy. Even if you owned all of the stocks in the economy, you will still be exposed to that risk. So we will learn a little bit about how to measure systematic risk. And then finally, we want to learn how does risk, the risk that we measure, how does it relate to the premium, which is the return, the additional return that we want stocks to have because they have higher risk than a treasury bill, than a risk-free asset. By how much do we want that compensation? What is the relationship between risk and return? So that's kind of the lay of the chapter. And what we start with by looking at that in chapter 11, we again recapping that for large portfolios, if we have portfolios made up of several stocks, investors will expect higher returns for higher risk. That's this idea that higher returns are linked with higher risk is generally true, but may not hold for each individual stock. And the reason it does not hold for each individual stock at every instant of time, it is because of that unique risk, because of that unsystematic risk, which is random in nature. You cannot predict when a certain stock gets hit with a bad news or stumbles upon some good news. You cannot predict it. So because of that, it may be that sometimes this relationship between higher return and higher risk may not play out. However, when we combine stocks into a portfolio, then that becomes less of an issue because that unsystematic risk is zeroed out, meaning it has no impact on the overall risk of the portfolio. Thus, the overall risk of the portfolio essentially depends upon the systematic risk. So stocks have both unsystematic risk and systematic risk, but this is the key part. Only systematic risk is rewarded. And since systematic risk is rewarded, any rational investor, a logical investor, somebody who's investing with their minds, using logic to invest, they should diversify. Because diversification will essentially eliminate the unsystematic risk. Okay. So now as we combine stocks into a portfolio, so this is a portfolio. And this portfolio, let's say, is made up of two stocks, A and B. You can think of IBM and let's say GE. Those are the two stocks in our portfolio. Then what is the proportion of my investment in stock A? Well, that will depend upon how much I have invested in stock A divided by my total investment. For the purposes of this class, we are going to be concentrating on essentially two stock portfolios. Of course, in real life, that's not going to be the case. In real life, you will have a multi-stock portfolio, but for the purposes of this course and this class, we will limit ourselves to a two-stock portfolio. Thus, for a two-stock portfolio, weight in stock A plus weight in stock B has to add up to 1, because this weight will always be a fraction. For example, if you had $100 to invest in your portfolio, and you bought $40 worth of stock B and $60 worth of stock A, then weight of A would be the $60 worth of stock A that you bought divided by the total wealth that you are investing in this particular portfolio, which is 100, so that would add up to 0.6. And similarly then, weight B would be 40 divided by 100, that would be 0.4. That means 0.6 plus 0.4 will be 1. And this relationship will be true every time. So here is a quick example. Portfolio, 200 shares of Apple at $200 a piece, and then 100 shares of Coke at $60 a piece. So weight of Apple would be 200 shares at $200 divided by 100,000. Why 100? So that would be, so 200 shares, that would be 40,000 divided by 100,000. This 100,000 is essentially 200 times 200 plus 100, not 1,000, this is 100, 100 times 60. Actually, this should be this should be 1,000 shares actually. There's something wrong with the numbers. This is 4. That's 40,000. And this is going to be 1,000 times 60, which should be 60,000. Okay, so that's how we would get 100,000 in the denominator. So that will give us a weight of 0.4 and 0.6, and of course 0.4 plus 0.6 will add up to 1. So now that we have developed the weights, how much we are, in what proportion we are investing in our portfolio, then the next question, the next most important question is, what is going to be the return now on my portfolio? RP stands for the return on my portfolio. And the return on my portfolio is simply going to be the weighted average of the returns in your stock. So for two stocks, RP would be WARA plus WBRB. Okay, and that's what you need to be aware of, because we're limiting our analysis to only two stocks. So here you have invested $100,000 to buy 200 shares of Apple at $200 per share, which is $40,000, and 1,000 shares of Coke at $60 per share, which is $60,000. if Apple stock goes up to 240 and Coke stocks falls to 57, and neither of them are paying any dividends, what is the new value of your portfolio, and how much return did your portfolio earn? So the initial value that you have in your portfolio, you have an initial value of your portfolio is going to be 100,000. That's what you started off with, right? Now in your portfolio, Apple changes its price from 200 to 240. That means there's a $40 gain in share price. Coke changes from 60 to 57. That means there's a $3 loss in share price. So so the value of your portfolio now would be 200 times 240, which is for Apple, 48,000. And value of Coke is going to be 1,000 times 57, which is going to 57,000. So the new value of your portfolio is going to be 105,000. Initial value was 100,000. So the return on your portfolio is 5%, which is 105,000 minus 100,000 divided by 100,000, which would be 0.05 or 5%. So what's the return on Apple? Apple, there was a capital gain of $40 on a $200 investment. That means that's a 20% return on Apple. For Coke, there is a $3 loss on a $60 investment, or our loss is 5%. If we apply that to the two stock portfolio, we had 40% invested in Apple, which gained 20%. We had 60% invested in Coke, which lost 5%. So we do the math, comes out to the same exact 5%. So there are two approaches of doing this. We can either calculate the new value of the portfolio, determine the old value, then calculate return on the portfolio, or simply directly calculate the return of each stock, and then apply that to this formula, the two stock formula. The general formula is WARA plus WBRB. We can apply that, and both processes will give you the same answer. So what is now the weighting after prices have changed? After prices have changed, the new weights are, again, based on the new stock prices. You have new weights on Apple and Coke. Okay. So initial portfolio was 60-40. Then because Apple stock increased, so the proportion of Apple in your portfolio went up to 45%, and the proportion of Coke in your portfolio went down to 54%. Okay. Similar problem over here. You can practice this on your own. Just the numbers have been changed. Just work them out and make sure that you are able to replicate the answers that we had. You're able to replicate the process and get to the answers to this problem. So in general, then we can say that the expected return of a portfolio, E stands for expected, meaning the future. In the future, this is what I'm hoping that the return on my portfolio will be the weight in stock A that I have multiplied by the expected return that I have for stock A, plus the weight that I want to invest into stock B multiplied by the expected return on stock B. And that will give us the expected return on the portfolio for a two-stock process, for a two-stock portfolio. So this just recaps how to calculate portfolio weight, how to calculate portfolio return, and how to calculate expected return. You are limited to 2 stocks right now. That's your goal. Don't worry about multi-stock portfolios for the moment. Okay. So similar question, you have invested 10,000 in Boeing and 30,000 in Merck. You expect a return of 10% for Boeing and 16% for Merck. What is the expected return for your portfolio? So that means you had invested 10,000. So weight, let me do this here. Weight in Boeing is going to be 10,000 divided by the total investment that you're making, which is 30,000 in Merck plus 10,000 in Boeing. So that's 40,000, 10,000 over 40,000. That's 25%. Similarly, what will be the weight in Merck? Will be 30,000 divided by 40,000, which would be 0.75 or 75%. So once I have these two weights, then I also know the expected return for Boeing. Expected return for Boeing is 10%, and expected return for Merck is 16%. Then just a matter of directly plugging that into our equation over here. Expected return for the portfolio, 25% in Boeing, multiplied by 10% expected return, 75% in Merck, multiplied by 16% expected return. So the expected return for the portfolio would be 14.5%. Okay. Similarly, you can work on some of these other similar problems. Once we get past the return question, the next question that comes up is what is going to be the volatility of the portfolio? Volatility is another way of saying how do we determine the risk of the portfolio? Because as investors, you not only care about return, which is your reward, but you also care about risk, which is the danger that your portfolio faces. And you want to know that for the danger that your portfolio faces, are you adequately being compensated? So what happens when we combine now Merck and Boeing into a portfolio? Well, some of the risk, the unsystematic risk of Boeing and Merck, they get eliminated through just diversification. So the simple adding of stocks to a portfolio should eliminate certain risks. And the risks that get eliminated, we call that unsystematic risk or risk that is specific to Merck or Boeing. But there are some risk that is common. Stocks also share some common risk. And because of that common risk, I cannot eliminate all risk in a portfolio. So the volatility of a portfolio is the total risk, which is to be measured, just like for a stock, we measure that as standard deviation of the portfolio. That's the total volatility. But then we are going to focus on the common risk part of the volatility and not consider the unique risk part of that volatility. So total risk in a portfolio is made up of two things. unsystematic risk and systematic risk. The unsystematic part of the risk gets eliminated through addition of more and more stocks to the portfolio. If I only have 2 stocks in a portfolio, I probably do not eliminate all of the unsystematic risk, but I may eliminate some of it. But if I add sufficiently large number of stocks to my portfolio, it is possible for me to eliminate all of that unsystematic risk, so that the risk component that is left for me is the systematic component. So we'll learn about that later. But the total risk, when we think about total risk, if we are talking about the standard deviation of not the stocks, but the portfolio. So let's take a look at how do we measure that. So here we have 3 stocks, and for these 3 stocks, we have year-by-year return. So essentially what we have over here is what we call a time series of returns. So based on this time series, what we have, we use this time series to calculate average return or mean return. This is average or mean. And what do? We learned that in chapter 11. We add up these numbers and we divide that by the 6 observations that we have. And we see that the average return for all 3 stocks are the same. Just happens to be. This was an unusual situation, but it happens to be the same. Then we calculate volatility. Volatility is sigma, our standard deviation. We also learned that in chapter 11, how to calculate standard deviation. We take the deviation of each return from its mean value, then we square that deviation, we add up those squared deviations and divide it by 6 minus 1, n minus 1, to give us, and then we take the square root of all that. That gives us standard deviation or volatility as 13.4%. Again, happens to be all 3 stocks have the same standard deviation. Now on the surface, if you find 2 stocks with the same return and same standard deviation, you may think, what would be the benefit of combining them? What would be the benefit of combining them into a portfolio? Why not just invest in either North Air or West Air? Now here comes the power of diversification. We can see this over here. In this column over here, we have invested half in North Air and half in West Air. That means the weight in North Air is 0.5 and weight in West Air is 0.5. Now for each year, I can calculate the return on this portfolio. This is the portfolio. How do we calculate that? For the first one, it will be 0.5 times 21, this one, plus 0.5 times 0.5 times 9, which will be 15%. We are applying WARA plus WBRB, the simple formula that we started this chapter with. We repeat the process, 0.5 times 30 plus 0.5 times 21. That'll give us 25.5, and on and on and on. Then, once I have this series, okay, once I have this series, I'm going to erase all the slides, so just to remove all the clutter. Once I have this series, I can again engage in the same process. Add up these numbers, divide by 6, and to no surprise, we find that the return on this portfolio is also 10. Because return on portfolio made up of weight of North Air, return of North Air, plus weight of West Air, return of West Air would be 0.5 times the 10 plus 0.5 times this 10, which would of course be 10%, which is exactly what we get here. So either we apply this formula or we generate a new time series for the portfolio and then average it out. It gives us the same number. But here comes the most interesting part of this exercise. What happens when I calculate the standard deviation? What happens when I calculate the standard deviation of this portfolio? The standard deviation of this portfolio, sigma, comes out as 12.1. And again, to calculate standard deviation, what do? I take 15 minus 10, square that. 25.5 minus 10, square that, and so on and so forth. Take all those squared numbers, add them up, and divide that by n minus 1, 6 minus 1, which is 5, and that'll give me variance. I take the square root of that variance, that gives me this sigma. So this is sigma for my portfolio, this is return for my portfolio. So the return number did not change because these two numbers were identical. But what is interesting now, the sigma for my portfolio is lower than the sigma for either of North Air and West Air. So had we stayed in North Air or West Air, we would have earned 10% return with a standard deviation of 13.4. By combining them 50-50 into a portfolio, I have preserved my return, but I have reduced my risk. Why wouldn't we want that? To preserve the return and reduce the risk. I am getting the same reward with less danger. So of course I would want to combine my stocks into a portfolio. I repeat that same process, but this time I do half in West Air and half in Texoil. So again, I calculate year by year return by applying this equation. I create a time series, take the average, same 10%, again, for the same reasons as before, but here again comes the interesting part. Sigma of the portfolio is even lower. So by combining North Air and West Air, I lowered my risk, but by combining these two, I lowered my risk, but by combining these two, I further lowered my risk. So if I were to choose between investing in either North Air, West Air, or Texoil, or some combination of them, what should I do? And the unequivocal answer should be, we should do this. Why? Because I get the same reward as investing in any one stock, but I reduce my risk by more than 50%. It goes from 13.4 to 5.1. So something is going on over here, right? Something is going on in these two risk calculations. What is it? What is it going on? What is going on over here is that by combining them into a portfolio, I'm beginning to eliminate their unsystematic risk. When we had stocks by themselves, this 13.4 was made up of both the systematic risk plus the unsystematic risk. When I combined them into a portfolio, I began to reduce my unsystematic risk, and because of that, the portfolio risk went down significantly. Portfolio risk went down significantly. I have not eliminated all of the unsystematic risk, but I have significantly mitigated it. So then the question comes, why for this portfolio the risk reduction was less than for portfolio 2. Why had portfolio 2 greater reduction in risk than the reduction in risk that we see in portfolio 1? And the answer to that question is a little bit tricky. It requires a little bit more observation. Notice what's happening between North Air and West Air. First of all, both of them are airline company. Both of them are in the same industry. So not only they're exposed to the same set of systematic factors as all stocks are exposed to, but even their unsystematic factors are somewhat similar. Not the same, but similar. Why? Because both are in the airline industry. Both face the same type of demand and supply as the industry faces. Both face similar types of industry-specific risks that may come from either regulation, environmental issues, demand from customers, demand for travel, people's disposable income, and all of those things that impact the price of an airline stock. But when we look at West Air and Tex Oil, they are two companies in two separate industries. And not only that, what is even more interesting, what is revenue for Tex Oil is cost for West Air. Tex Oil makes money when oil prices go up, right? So when oil prices increase, Tex Oil makes more money. But if oil prices go up, and oil being one of the main cost centers for an airline company, one of the main sources of cost, expenses for the airline company, then if oil prices go up, airline stocks will be suffering, airline profitability will suffer. So, and this situation that there are unsystematic risks between West Air and Tex Oil are significantly different from each other. So when oil prices rise, Tex Oil stock does well, West Air does poorly. When oil prices fall, Tex Oil does poorly, West Air does well. That scenario you can begin to see in their returns. If you compare the year-by-year return, what do you see? Tex Oil not doing well, West Air doing very well. Tex Oil doing well, West Air not doing so well. Not exactly one-to-one, but there is a significant relationship, and the relationship is negative correlation or correlationship. On the other hand, when you look at North Air and West Air, notice stocks doing well, both of them together, and when they do poorly, both of them do poorly. So these two stocks are positively correlated. Positively correlated. So the driver for this risk reduction is what? Is the statistical term that we call correlation, also measured through the Greek letter rho. Correlation. Correlation has very interesting properties. And by the way, let me also point out this over here. You can see this, what happens when we combining West Air with North Air. Focus on the yellow bar. Both stocks are doing well, the yellow bar does well. Both stocks do poorly, yellow bar does poorly. But focus over here on the yellow bar between West Air and so one stock does well, one stock does poorly, yellow is stable. Purple does poorly, this stock does well, yellow is still positive. So notice that the yellow remains positive in all 5 years. But over here, the yellow fluctuates based on what is happening to the both stock. So this is again a picture that depicts to you the power of diversification or lack thereof. What would you say for this particular picture? Not well diversified. For this picture, you would say it's very well diversified. Why? Because look at the yellow bars, the light yellow bars. They're stable and steady. So this is a good example of the power of diversification. So to recap, by combining stocks into a portfolio, we reduce risk. Why is risk being reduced? Because unsystematic risk is being pushed out of the portfolio, and the remaining risk is only the systematic risk. So what makes risk reduction more possible? It is more possible to the extent that we can eliminate that risk based on the degree to which the stocks move together. When they don't move together, like Texoil and West Air, we gain higher benefit from diversification. When they move together, like West Air and North Air, we get less benefits from diversification. So that's recapped over here in these two bullets. So how do we measure this co-movement? The metric that we use in statistics is called correlation. We're not going to learn in this course how to measure correlation. In an advanced finance course or an investment course, you learn that. But over here, what you need to know is correlation essentially measures the degree to which the stocks either move or do not move together. And statistically, correlation will always be bounded between these two numbers. Correlation is always bounded between -1 and +1. The minimum correlation that you can have is -1, which means you have the greatest benefit from correlation. And when correlation is +1, you have the least benefit or no benefit from correlation. So correlation is -1. It means the stocks move oppositely. And if correlation is +1, it means the stocks move together. And then some combination in between. If it is 0, it means they're uncorrelated. They don't move as much. So you can see over here stocks that would tend to move together, Ford and Goodyear, maybe Ford and Apple. But over here, you may have West Air and Texoil, because they are less likely to be related to each other. Again, for the reasons that we talked about before, what is revenue to Texoil is cost to West Air. So how do we then measure correlation? Correlation is measured, again, this is a statistical equation that you just need to know. It is measured by taking the covariance between the two stocks. So correlation, say, between West Air and Texoil would be what we define as the covariance between the return on West Air and the return on Texoil divided by the standard deviation of West Air multiplied by the standard deviation of Texoil. So that's how we would calculate correlation. This part you already know. You already know how to calculate the standard deviations of these two stocks. We just did that at the very beginning of this discussion. What is new over here is how to calculate covariance. This will be outside the scope of this class to calculate covariance, so it will be something that will be provided to you. But you just need to know what this equation does. And you also need to know that this equation can be rewritten or manipulated to say that covariance between West Air and Texoil is correlation between West Air and Texoil times standard deviation of West Air times standard deviation of Texoil. Just restating the equation. I can either write the equation as covariance equals correlation times standard deviation, or I can write correlation as covariance divided by the product of the standard deviation. Okay. So over here, what we have is a table that shows different stocks: Apple, Microsoft, Target, Starbucks, Goodyear, and Ford. In this row, what we have is the standard deviation and Berkshire Hathaway. In this row that we have is standard deviation each of the stocks. So some stocks are more volatile, some stocks are less volatile. So you can see that a company like Berkshire Hathaway has the least volatility, and a stock like Ford has the most volatility, standalone. And then what we have over here is called the correlation matrix. So what does this measure? 1 is along the diagonal of that matrix. Why? Because over here, I'm looking at the correlation of Apple with Apple, Microsoft with Microsoft. Of course, there's going to be 1. They're the same stock, so they will be the same correlation with each other. But then what do I have? I have over here Apple's correlation with Microsoft. And over here, I also have Microsoft's correlation with Apple. And both numbers are the same, as it should be. The relationship between Apple and Microsoft, or Microsoft and Apple, is the same thing. So you can see that these two numbers are the same. Similarly, this number will be same as this number. So if I think of this matrix, I can draw a line like this, and I don't need to worry about these numbers. Because these numbers are the same as the numbers in the top. So essentially over here, I'm looking at Apple with Microsoft, Apple with Starbucks, Apple with Berkshire Hathaway. In the third row, I'm looking at over here Target with Starbucks, Target with Berkshire Hathaway, and so on and so forth. So those are the correlation numbers that we are seeing. So it's not coincidental that the correlation between like the two tech stocks are pretty high. Correlation between Ford and Goodyear is pretty high. If Ford does well, then the company that supplies tire to Ford is also going to do well. Correlation is pretty high there. Correlation is pretty low when I look at a holding company like Berkshire Hathaway with a tech company like Apple. Okay. One way to kind of visualize correlation is to create a scatter plot between, say, Apple returns and Berkshire Hathaway returns. Look at the dots. They're kind of clustered over here without much trend line. But when I regress Goodyear returns with Ford returns, look at the clustering. The clustering has an unmistakable trend line. So it gives you a sense of how to visualize correlation. What does that number translate to when I try to visualize it? So let me stop over here for the first part, and then we'll continue in the second part.